Today we are going to discuss about acceleration. What is meant by acceleration? Acceleration simply means rate of change of velocity with respect to time. Accelerations are of three types. First is average acceleration, second is instantaneous acceleration, and third is relative acceleration. Let's see how average acceleration is defined. Average acceleration can be defined as change in velocity divided by time interval. As shown in the graph, let velocity of a body at time t initial and t final are v initial and v final respectively. For defining average acceleration, time interval must be defined because in different time interval, average acceleration of a body may be different. We are defining average acceleration between t initial and t final. Since velocities at t initial and t final are v initial and v final respectively, so average acceleration between t initial and t final is equal to v final minus v initial divided by t final minus t initial. That is equal to delta v vector upon delta t. That is equal to tan theta. That is equal to slope of chord of velocity time curve between given time limits. So whenever average acceleration is to be defined, you come to know that time interval need to be specified. Now let's see how instant acceleration is to be defined. Instant acceleration is the acceleration of a body at a given instant, which can be defined equal to limit delta t tends to 0, delta v vector upon delta t. That is equal to dv upon dt. That is equal to tan phi. That is equal to slope of tangent of velocity time curve at a given instant. From this equation, we can also conclude since acceleration equal to dv upon dt, so dv equal to a dt. So whenever acceleration time graph is given to us, we can simply calculate the area bounded by acceleration time curve, bounded by time axis. We can simply calculate the area between acceleration time curve bounded by time axis with suitable algebraic sign that will give us change in velocity. Always remember that area under acceleration time curve bounded by time axis with suitable algebraic sign gives us change in velocity. Why suitable algebraic sign? Because acceleration is a vector quantity. Whenever acceleration will be positive, velocity has to increase. Whenever acceleration is negative, velocity has to decrease. Whenever acceleration is zero, velocity has to remain constant. If in a motion average acceleration is equal to instant acceleration, then such type of motion is said to be uniform acceleratory motion. Uniform acceleratory motion is not a uniform motion, because in a uniform motion velocity remains constant, while in uniform acceleratory motion velocity changes. In uniform acceleratory motion, change in velocity remains directly proportional to time interval, but velocity changes. If we want to write general equations of uniform acceleratory motion, and if we are interested in plotting the graphs for uniform acceleratory motion, the graph will be like this. For acceleration time curve, graph will be parallel to time axis. For velocity time curve, graph of velocity time will make some inclination with the time axis. And it will pass through origin if its initial velocity is 0, and it will pass through some point on velocity axis if its initial velocity is something. And the graph between position time curve will be parabolic in nature.